Hey there, what is up? Welcome to Radical Academy, and my name is Mike Wada. In this video, I'm going to teach you everything that you need to understand about isomers. So this is still chemistry grade 12. So if you're new to my channel, please don't forget to subscribe and like, and also share this channel to other people, friends, or families that might also be interested in these contents. So without much further ado, we are going to continue where we left from, okay? So last time, in the last video, which I produced, rather published, I talked about alkanes and alkenes, and then I talked about even the type of functions and even some other stuffs, okay? But in this video specifically, I'm going to teach you everything that you need to understand about isomers. So we are going to dive into something called isomers. We are going to understand how you can be able to come up with an isomer. We're going to be able to define what is an isomer, and then also we are going to talk about what is the definition of an isomer. Okay, so now without much further ado, let's now jump into that. Okay, so now what is an isomer? So an isomer is simply a molecular structure, okay, or a substance or a compound that can have the same molecular formula but different structural formula. So most of the isomers have been known to be very important and useful in the branch of organic chemistry, in the field of chemistry. So most of these isomers they are very essential, more especially to the production of medicine and other vital substances that cannot be manufactured from the prime substances that we have at hand. Okay, so now in terms of isomers, we have to understand that there is a system that you need to understand and learn in order to come up with the names and obviously how to draw the structural formula in terms of our isomers. Okay, knowing that regardless of how complex the isomers may be in terms of structure, we are drawing these isomers from one standard molecular formula. Okay, so now I'll begin by talking about isomers in alkenes. Okay, so the isomers in alkanes, meaning the single bond between the carbon to carbon, okay, or the saturated hydrocarbons. So how can we name an isomer? Okay, an isomer which has the parent hydrocarbon of nature an alkane. Okay, so now isomers, these are substances or compounds, more especially in organic chemistry. Isomers are substances that have got the same molecular formula but different structural formula. So now, what does that mean? Okay, so I'll give an example. We can have a formula, like we can have a molecular formula of propane. Okay, so propane is an alkane, okay, is an hydrocarbon which is called an alkane, okay, and this propane is a single bond hydrocarbon, okay. So how can I come up with the structure of, or with the isomer? Can I have more than one isomer? can have just a single isomer in this kind of hydrocarbon propane. Okay. So now let us look at the board, and then you can see on the board that I've got this an alkane, which is simply called propane. So this is the actual class member of the alkanes, which is on number 3, meaning it has got 3 carbon in it. You can see that the longer carbon, the number of carbon, the longer chain is unbranched carbon. Hydrocarbon is 3. So now what this means is that this is the normal propane. This is the propane that each one of you knows. Even someone who can just learn today can simply comprehend this kind of propane, or which is a standard isomer, like the normal isomer, but we have not actually altered anything. Now, how do we go about coming up with an isomer? So you have to understand that for you to come up with an isomer, you have to understand certain procedures, certain nomenclature system that has been put forward by these chemical scientists or chemists, in order for everyone who is studying organic chemistry to have the same system of naming the compounds, or the possible way in which you can rearrange these atoms so that you can get obviously something that is very usual but unlike unusual, so that everyone out there can be able to understand and obviously have an insight of what your structure is all about. Okay, so there is a system that we call nomenclature system. It is a system that has been provided, okay, when you are coming up the name, and obviously, the correct name, okay. So someone can just come up with any kind of a name in terms of an isomer, okay. You can call it whatever you want. You can, with where we ended at. Okay, so we were saying that when you look at the compound on the board, we are simply talking about this is a propane, and I just want to show you how you can be able to come up with the actual name in terms of an isomer. Okay, so we know that this one is a propane, but how can you just come up with the name? Okay, different structures, and then each of those structures is going to have its own name based on the structure that you are going to come up with. Okay, so like I've mentioned previously, that there is actually something that we have to understand and also to follow, and this is what we call the nomenclature system. Okay, so the nomenclature system is a system in which these compound isomers, okay, we follow the procedures, the naming criteria, and so on and so forth. So just stick around and let us understand how we can be able to come up with the name of an isomer. Okay. So now, what you need to understand also is the idea that there are certain procedures, like I've said, the system of the nomenclature system. Okay, so what you will see is a propane. So instead of me writing just the normal propane, what I'm going to do is I'm going to isolate. Okay, I'm going to isolate this part. Okay. Once I isolate this part, I'm going to change the position of this part, okay? So meaning, if I do that, I'm going to put this one down here, okay? Meaning, once I change the structure of this propane, which is an alkane, then it simply means that even the actual name of this propane is going to change, okay? Okay, so now, as you can see, what come up with another structure on the board. Okay. Now you can see that I switched off this last carbon, which was at this far end, and then just put the carbon down here. Now, the moment you do that, okay, you are also saying that the name of this is also a different one, okay, because the name of this isomer is fundamentally based on the structure of this isomer. So now, what is the name of this isomer? Okay, so when you're naming an isomer, the following procedures must be actually considered. So what we mean by that is you are going to count, first of all, the unbranched chain. Okay, so we have, this is our first carbon, this is our second carbon. Okay. Now, you can also do the opposite of in terms of counting. I start from left going to the right side, and then I can also do the same. If this is the first carbon going to the left, this is the second carbon. Okay. Now, the moment you do that, it is going to signify, or the reason why you're doing that is because you just want to locate the branching off. Okay, so you want to find the shortest distance possible that the branching off is taking place or has taken place. And that is the main key fundamentals in understanding isomers in organic chemistry. Okay, so you can see that if I'm counting from left going to the right, okay, this is the first carbon, the second carbon, then there is a branching off, okay. Now, this sounds okay if I didn't consider that there is an alternative in which I can also count the position of the branching off, or which one in terms of the counting will give me the shortest, point where the branching off is taking place. So if I count in the normal direction, you can say maybe if this was the only way or possible way in which you can count the number of carbon, okay, from left going to the right, the branching off, like this is a second carbon, branches off at carbon number 2. Okay, this is where we are finding the branching off. Now, if I do the opposite in terms of the branching off, then this simply means that this is the carbon, so now I'm doing the opposite numbering. Okay, so this is carbon 1, carbon 2. Now, at the very carbon 1, there is a branching off, and that is very fundamental and key in coming up with the name of an isomer that you can see on the board. So what is going to happen is that now we have located the branching off, and then you have to identify, okay, the derivative from the branching off, okay, like the group or the substituent, okay, the substituent are kind of a radical, okay. So this part, okay. Now, if you go back in the other videos that I did, you discover that there is a carbon, okay, there is a carbon which has 4 hydrogen atoms, or there's an alkane which is methane, which has got 4 hydrogen atoms. Meaning, when you look at this, it's a carbon, it's the same thing, okay, but there is one missing part or one missing component, which is just you remove 1 hydrogen, okay, you remove 1 hydrogen, so it becomes like that, becomes CH3. Now, in organic chemistry, the CH3 is what we call the methyl group, okay, so it's a grouping that has got a name, a specific standard name called a methyl group. So if the branching off has got a nature of that kind of a compound, in short to say CH3 group, okay, so we call this one as the methyl. We call it the methyl group, okay. So you have to understand that the methyl group is a derivative, okay. It is coming from the methane, okay, because a methane alkane has 4 atoms of hydrogen, but we are just removing 1 hydrogen. So meth from the methane, okay, and then the hue is because it lacks 1 hydrogen there. Okay, so that makes sense. Now, so the position of the branching off is part of the naming system or the nomenclature system. Okay, that we have to understand. So now, what is the name going to be? So we have identified that the branching is taken off at carbon number 1, so that is the shortest way possible, or the easiest way at the first carbon. Okay, if I start from this numbering, the branching off is taking place at number 2, which is longer in terms of distance. Okay, but if you do the opposite, the bottom numbering, this shows you the shortest way or possible distance at which the branching is taking place. Okay, so this tells you to say, so the branching off is part of the naming 1. Okay, it is 1. Okay, and then because this part is also, a part of the naming, which is a methyl group. Okay, so 1, and now this one. Okay, so in organic chemistry, a compound in terms of the saturated, the hydrocarbon compound, the one with 2 carbon, okay, it is called ethane. Okay, so it is called ethane. So this is going to be 1. Okay, so we are going to call it 1-methyl ethane. Okay, so that's a simple name for this isomer. So the first, one of the most fundamental things that you have to understand in organic chemistry, more especially under isomers, is to understand at what number, okay, at what position of the carbon is a branching taking place. Okay, so that number, the position, okay, at the carbon position, is very fundamental as part of the name. And then also these groups that we'll continue even talking about even in the next videos that I'll also share probably in the coming time. And then you have to understand that the unbranched chain, okay, will give us the root name. Okay, so the root name is this unbranched chain, which has got 2 carbons. So when you go to that table, which I also share in the next coming videos, the parent name of an hydrocarbon, which has got the 2 carbon in it, is ethane. Okay, so eth means 2 carbon. Okay, so you have to understand that. Okay, so I'm gonna give you another last example about, so that we can just understand more about isomers, different ways in which we can also come up with these isomers. Okay, so now before I get to that part, you must ask yourself to say, is there any other possible way in which we can, apart from this structure or isomer, is there another way in which we can rearrange the atoms, okay, and come up with another new structure other than this? Okay, so if there is no possibility about a structure that you can come up with, then this is the only structure that is possible in terms of isomers. Okay, so stay tuned. Let us look at one last example about isomers under the alkanes. Okay, so we also talk about the isomers under the alkenes, which are the double and unsaturated hydrocarbons. Okay, so just stay tuned and let's see how we can come up with another complex, Okay, so this is our example, another example concerning isomer, how you can name isomers. So I hope from the previous example you have gotten some of the key fundamentals, a concept that I've just talked about. So now, the other last example that I want to give under the alkanes, hydrocarbon, is that I want you to understand and also see what is on the board. Is that the kind of structure that you see, it's the same thing, okay, with the previous one, except that this one is what is known as a condensation kind of a formula. So we have condensed the structural formula into these tiny kind of groups. So you can see that it's a simple one. So if, for example, let's say I want to draw it, so I'm going to say okay. So now what you can simply see is that I've got on top what is called a condensation, a condensed formula or structure. That you can see this structure is the same as the one at the bottom in a green color. It's just the same thing. Now, when the number of carbons increases now, what that happens is that it gets to consume more space on your paper, for example, or in your book. So you want to actually use something that is very sensible and something that is very reasonable, okay? And that is the one on top. You want to condense the formula into something that is very easy and also, you know, reduce the amount of space consumed on your piece of paper. But either way, you are not limited to what kind of a drawing that you want to actually show the examiner, or maybe what kind of a drawing you're required to do. That's your choice. That's an option. It's all up to you. But the main point I want to put across is to understand that how can I come up with the name of an isomer of this structure, which is just on top. Okay, so now let's dive into that. Okay. Now, what you have to understand is the first procedure, the first idea or the criteria to follow when you're coming up with the name of this isomer is that you have to understand that you have first of all to count the number of carbon, like in terms of position. So this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4, this is carbon number 5, this is carbon number 6. So when you look at the branching off, when you look at the numbering that I've done, you will discover that when you go back to the normal, the alkanes, okay, we are calling them the alkane because they all contain single bonds, right? And that's what makes us more comfortable to understand what we're dealing with. So now, an alkane, okay, the class, the members of the hydrocarbons, the alkane that has got about 6 atoms of carbon, okay, or the number of carbons 6. So this is an hexane, okay. So we are not counting the branching off because obviously if I want to go this direction, 1, 2, 3, 4, okay, this will not give me the actual or the more numbers in terms of cannot even go to 6, okay. So the number one thing is that the numbering is important, okay. You have to be sure of the numbering, okay. So the idea why we are numbering is because we want to actually trace at which point, okay, at which point in terms of the branching off, in terms of the position, at what position of the carbon is that branching taking place, okay? Is that branching occurring? That is the idea, the main essence of numbering them, okay? Because we want to have the right way in which we can do the numbering, because that numbering should be the shortest way possible to reach at the branching point in terms of that branch there. Now, this is not the only way you can do the numbering, right? Because you don't want to make a mistake. So we want also to do the opposite numbering, so that we compare which of the two numberings will give us the possible shortest, position in terms of at which carbon, okay, at which position of the carbon is the branching has occurred, or is the branching occurring. So now this is going to be 1. So I'm going to start from right going to left, okay? 1, 2, 3, 4, 5, 6. So when you kind of look at the top numbering, okay? So the branching off, when you follow the top part of numbering, the branching is occurring at carbon number 4, okay? While the bottom part, when you count from left going to the right, is occurring at number 3. So we'll have to choose that numbering, okay, which is shorter or closer. So 3 obviously is closer as compared to 4. Okay, so we go for the shortest, position. Okay, so the shortest position at which the carbon, the branching off is occurring, it is at position of carbon number 3. So that becomes part of our naming of the name of the isomer. So this is going to be, 3, then you put the dash. Now, you look at this, the behavior, or rather the kind of the group, okay, that is has branched off from the main root or the parent carbon, okay, hydrocarbon. And this is the methyl group. Now, why are we calling it the methyl group? Is because this is just the derivative of the methane hydrocarbon. So just missing one hydrogen, and that becomes a group called a methyl group. Okay. So this is the methyl. So that is the methyl group. Okay. That's the methyl group. Okay. So this is the methyl group. Methyl group. Now, once you understand that, so 3 dash methyl. Now, what is the parent name? So the parent name is actually the Greek name, okay? So it's actually the Greek name, okay? So how many carbon, this long name, the long normal and branch chain, okay? In the straight line, okay? So 1, 2, 3, 4, 5, 6. Okay, so the name of an hydrocarbon with 6 carbons is called hexane. Okay, so you just take that now, hexane. Okay. So our name now is 3-methyl hexane. Okay. So this is how you can go about naming hydrocarbons. So if this video has been so, help to you, it has been, you have gotten some of the key concepts that you never knew from a class, you never knew from when you studied just on your own, but you have found this video to be so informative, okay? So please give us a thumbs up, and also remember to subscribe, and also like and share this video so that you can help us to grow this channel. And it will be so grateful if you can just subscribe, and by clicking on the subscription button and then click all. So that's all we are asking from you, and then we'll keep on producing this kind of content, this kind of videos, so that you can also help you pass exams, so that you can understand things that you have never, that things that you have been having difficulties and challenges within your class. So this is a Radical Academy, and my name is Mike Wada, and I will see you in the next video. Please, thank you so much.